The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, press to connect, and Zoom Lock Push to connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. Let's start off. How was your week?
Eventful.
It's only, it's freaking, Wednesday?
Wednesday. It should have been my Friday. I was supposed to be off tomorrow, but that ain't happening till at least midday. So we're starting up another CO2 rack. Learned a lot about XM controllers, that only certain XM controllers could read a 0 to 1000 psi transducer, specifically one of them.
What do you mean?
Different, you have to have a special version that is only released to one OEM and one customer.
Oh, but so what's the max on all of them? 650 because they're on the
870.
What?
870.
There's a wait. Is there a specific? I thought the transducers were up to only 650.
Apparently, somebody must make an 870.
Oh, never seen it. So
I found a 750 today.
Okay. So what transducer was on there? 1,000?
Thousands. Because it's a 90 bar rack. So
just 1,000.
1,000.
1,000. Okay.
So there was 4 of them, and these particular XMs require a hotkey in order to get flashed.
The little plug-in thingy.
Yeah. Yeah, there's only 5 in the United States.
What?
Yes.
Wild.
The OEM has one, and Copeland has the rest. And none of them are at said job site.
I thought you can buy them, though. Can't you buy them? Like, you have to have the software to flash them, but you could potentially do that, no?
Not for those. Really? I don't know.
They all look kind of the same, where they have the 4 or 5 little pins.
I think it is, but I don't know if it's different software. I'm not sure. We couldn't use Wizman, I know that, to do it. Yeah. So in order to get this,
you're gonna be really irritated right now. What? Guarantee it. Oh yeah. Just hold on. I'm just.
Yeah, I have one of those, but it's no way to put a program on it.
Okay, but so you'd have to have the thinger to
to
do the program, right? Okay.
Regardless of that, it's That was shot. So I had to send somebody to a different job site to go steal transducers, 650s, out of a bunch of other coils in order to get this to run for the day, because this has been like nonstop. Go to start this thing, and it's just like every roadblock, every which way. So can't get that. Then randomly there's a board with this is reading voltage through all the inputs. Just all the transducers are reading like 200 pounds.
So I do want to tell you something. I don't know what you're going to tell me that you found, but I'm pretty sure that the guys, when we were doing one of the classes, ended up smoking a PID board, because so if something is set for not voltage but milliamps, it basically wants to put that voltage on the line so it can create that amperage. So is that kind of what you were seeing, or what's going on?
No, in our case, a board out. And it was like sending voltage to every input. So get that all taken care of. And then we're trying to figure out how to make this CO2 rack work. It's got 4 forms of heat reclaim, everything else. And so we've just been like chipping away at it. It's just been like one thing after another. So I got to pump this thing back down on Monday and swap these transistors out when we update everything. So that was a kick in the balls. And then randomly the transformer blew up on the rack.
Sweet.
So cut that out. I had him pull a 120 volt control circuit because I didn't want the transformer there anyway, because I think it's stupid to have a control transformer on a rack when you could just pull a control circuit when it's 20 feet away. I'd much rather have a resettable breaker than fuses. We ended up having to cut all that out, and then it's just been like back and forth trying to get this water loop bled. I still can't get the geo loop bled. I've been trying for 3 days.
What?
It's still got air in it. It's you could hear it gargling at the header.
Well, that's not good.
And there's no way to get it out besides shutting it down and hooking up to it with a pump truck and like violently forcing it through the wells.
Couldn't you like essentially pull a vacuum?
You'd just be pulling it out of the wells at that point, I would think.
Whoa, that's trippy. Sorry.
Holy cow.
Messed up. Sorry. I was trying to say something.
So yeah, it's been my thing. I've been messing around with the E3, getting a little bit deeper into that, and then messing around with some of the other stuff, like some of the backnet stuff. It's very interesting. Yeah, I don't have that. If I had, that'd be cool.
I'm just saying.
I don't have that.
You could buy that.
Either did the four Copeland guys that were there.
Yeah, I heard the Aussie was there.
The whole team is there.
Really?
And they'll be there all next week too.
Sweet.
So
did you figure out your VFD cycling yet?
VFD cycling.
Your VFD.
Oh, dude, we still can't get the water loop to be right. So I don't know if the sensor's bad at this point. So we're gonna call tomorrow and call this BTU meter company, because something doesn't add up, because there's flow sensors on the racks, digital flow sensors, and they're all good.
What do you mean they're good? How do you know that they're actually giving you the right flow?
I'm getting my TD in and out. I'm getting my pressure drop across the coil or across the heat exchanger, and it has like a reading with a bunch of LED lights of where they baseline this thing at the factory. Because this rack actually ran at the factory. So they baselined and set this thing at the factory.
Really?
So they had it hooked up for a month on a dock.
Oh, shit.
With boilers and another rack running it.
You can actually hook up a controller to this thing. This is pretty neat. I'm going to see how much they are.
The controller to what?
Yeah, that's what I'm going to show you. Sorry, I can't stop looking at this now. So apparently you can hook up the controller, right, of whatever you're trying to pull the program from, and then you can program it into the hockey copy.
So that's interesting.
Boss man,
yeah, that ain't gonna happen.
That's not something that they lay in the rack.
Had a random weird issue with the XMs too, so we went to go start up the freezer coils. And like always, I'll make the fans P6, make them run off of probe 6, which is your suction temp. Okay.
Yeah.
In this version of the XM,
you couldn't.
Well, in the E3, it let you. In the actual XM, it would read faulty, and it would read 168 degrees on the fan probe. If you looked at the inputs, you could only use P1 or P2. If you use P6, it defaulted to 168 degrees.
Awesome.
So that was a little bit of a steep learning curve there.
So this was like one specific, was it a firmware version, part number? Like
it's one specific firmware version that only goes to 0 zone in Amazon.
Interesting.
Like it's only used for hot gas defrost for them because it's the 0 to 1000 transducer. Because I'm pretty sure I wanted this to be CC200s because it would have been a lot more flexible. Because of the CC200, you could make it a 0 to 2000 if you want. Doesn't matter. Then we had a slight scare because somebody came upstairs and was like, hey, the low temp coil is only rated for 300 pounds. And I'm like, excuse me? Like I hung the medium temp coils and checked those in. I never checked the low temps because the fitters did it.
Not anymore.
Print. I'm like looking at it. I'm like, 300 pounds. I've never seen a coil rated for 300 pounds. Like even the DX coils rated way higher than that.
I think it's 350 or 400.
No, it's higher than that because the reliefs on a rack are 450.
Oh yeah. Oh, okay. All right. Fair enough. Yeah, because you got 650 on. No, you said regular DX.
Yeah.
Usually those are 450.
Yeah. So like I'm looking at the coil. I'm like, man, something doesn't look right. Look at the one coil. It says 1,700 pounds. Go to the next one. It says 300.
Oh no.
Then I scan a little Reef Plus tag and it says 45 bar. I'm like, I sworn when I was piping these, like the side of the coil was tagged. On the side of the coil, 90 bar, 90 bar, 90 bar. It's written everywhere. I'm like, what the which one is it? Thank God they tagged the coils wrong.
Oh, okay.
So, yeah, that was my week. And I've been driving 5 hours home, to and from work every day. So that's been a real treat. They decided to tear up every east-west road in Chicago at the same time. So it's been like a 3-hour ride home every day.
I almost had to put the kids in the closet the other night. Not for any parenting reasons. We had tornadoes really bad. The sirens were going off all night. Yeah, it was getting pretty hairy. Like they demolished same town, just like 9 miles north of where I'm at. So that was fun. Trying to think of things. I fixed tons of shit this week, but I can't remember what I did. No idea. Can't remember.
Well, guys, we want to talk some more basic rack stuff. Sure. So we go over some more of that stuff. So what are you thinking?
I don't know. Yeah, actually, let's talk. So I saw something on Facebook today because like that's my pooping time, and usually that's when I peruse stuff. Now you guys know the secret. That's what I'm doing when I'm commenting on Facebook. But I saw the one thing where the ball looked like it looked crushed. You see that?
I just seen it.
Yeah. So I thought it was one thing. I've seen this happen before, typically in the discharge line for any oil separator. And what I'm talking about, if you didn't see the picture, it was an oil float. And it was smushed. It was just smushed. So when whoever took it out, like it looked like someone just sat on it and then just let it work and then shoved it back up in there. A little bit higher. Looks like a potato. There we go. I'll try to bring it up here in a minute. But basically it was gnarly looking. Nope, not that. So they basically, like I said, it was smashed, and I'll show a picture here in a minute. But my thought is that I've seen where the discharge check valve on the discharge line basically has either failed or the rack didn't have one. You could see on his graphs, and I don't know what the heck his high pressure was because I saw that thing shoot. Did you see the pressure transducer? It looked like it shot all the way up to almost 400 or 500 pounds and then shut off. And then you could see it come down. So if there's no check valve or the check valve is malfunctioned, that liquid will essentially, if the fans are still rolling, it's now going to condense all that vapor into a liquid and essentially come down the pipe, especially if there's no little Humpty Hump right on the main discharge line, and then go back into the oil separator. And then as soon as the rack turns on, you got this big thing of liquid in there. And then you have this violent high temperature discharge gas just rolling through. And if you've ever used discharge gas to boil off any liquid that was in a reservoir, you'll see it like rapidly expands, right? This is my thought. Yours?
No, that's about right. It rapidly expands and causes all that turbulence in there, and it just crushes the ball. And you usually see it rip off. Like every time I've seen it, it's been ripped off and like slightly crushed. Yeah. But that check valve sticks or all that liquid comes dumping down on top of it, and then it goes to start, and it can't force it out that hole fast enough.
Yeah. And
so then it just crushes. What's worse, the valve plate stuck in the oil separator outlet.
One more time?
The valve plate stuck in the oil separator outlet on the centrifugals.
Oh. Tell us what happens.
So if you get like a centrifugal separator and you got that packed angle valve in the bottom, doesn't matter what manufacturer it is, they're all susceptible to it because it's a small opening on the bottom and you got no float to drop. Now, if it's got a float, it's not a big deal. But if it's a non-float type separator with reservoir in it, it's a big deal because you maybe drop down to 3/8 to half an inch at the bottom. So what ends up happening is you get a valve plate material or discus pack that explodes. And what happens is all that material gets crushed up and then goes through the separator and gets stuck in the valve and the outlet. The first time I seen it was, of course, at 1 o'clock in the morning at a Walmart, like on a roof, and I could not get oil to any of the compressors. I show up, one of them's got blown valve plate, shut it off, and then I'm like looking, I'm like, none of the oil's leaving the separator. Like, the hell? Like, nothing in the sight glass, anything. So I'm looking around, I'm like, what is that black piece in there? It's like a chunk of like material in there. It's just packed solid valve plate to the point where I'm like fishing it out with braze rod.
Look at that freaking thing.
Oh, that thing is crushed.
That's what I'm saying, dude. Like, I wish you would have took, and I'll look here in a second, because dude, there's no way that could be crushed by anything else other than what we were just describing. You know what I mean? There was another picture he had. I don't know if you had. Holy shit. Yeah, unfortunately, he has no line that's obviously going in the side there. At least it should be. And then coming out the top, which he doesn't have a picture of. I was just curious if they're using, because doesn't it look like this is all fresh braze? This doesn't look like
it looks fresh.
That's not factory. So my assumption is that they put a new one in and they were like, no need to check that, or either that or it just didn't have one from the get. But
they need the quick change oil separator from Colorado.
What?
Remember when I sent you that oil separator with the rotolocks around it?
Oh my God. That's golden. That's golden. Yeah. So there actually, you know what? Now that I think about it, it's actually two people called me this week about I know we were doing basic stuff, but this was a really good thing that got brought up. And I want to get your opinion on this because a guy showed me the picture once we found it. And I don't understand how the hell this actually happens. Downloads. Look at that. So this is a oil solenoid on the bottom of a Advanced rack. And because he wasn't getting oil to any of his compressors. And he finds something in there, right? And this is what he ends up finding. So it was a piece of rubber from the temperate filter. But Mike, like, how does that get through the screen that's supposed to be there before?
So did it have one of those inline screens or it was one of the older racks where it didn't have a screen?
This was a Kaiser rack.
I don't think Kaiser has an inline strainer.
Really? Okay.
They do on the ones now. They all seem to be using this mini strainer that Zero Zone started using. It's like a little mesh screen. Like, it's not as small as the Hill Phoenix one, so it doesn't plug up nearly as fast. But some of the original Advancers and the Kaiser ones didn't have screens in there. It would just plug up the valve.
Oh, okay. So that's probably what it was then. This is somewhere on the East Coast, so it might be a little elter.
Yeah, so it probably didn't have that. So just so you guys know, like a lot of these, I see this a lot, and it gets missed on startups. Those relays or those solenoids, a lot of them are DC coils. Danfoss and CPC boards are not rated for DC voltage on the contacts.
Yeah, I argued with a guy 2 days ago because he had a problem where he showed me that he replaced the relay, like those solid state relays that you'll replace the relay, but if you didn't pay attention and you didn't realize there was like ohms on there on the base, that the ohms was basically weld out or whatever. I don't know what causes it, but essentially if you don't replace the base, a lot of times it'll burn out the relay shortly thereafter again, right? Yeah, he put on a regular relay, like not a solid state relay. So the difference is that a solid state basically has no moving parts. A regular conventional mechanical relay has moving parts. So
how long did that last?
Huh?
How long did that last?
It's still running. And I told him, I was like, dude, I don't really like that you put that in there. I said, I would recommend you taking it out, but I don't know if he did. But yeah, because we had a conversation where someone was telling me about a Costco rack. And they're like, yeah, it's really because we were just talking about what actually turns those on, what actually empowers the relay. And apparently it's a signal coming from microthermal, coming from a actual relay. He's like, yeah, we keep having the boards for the relays just go out. And I'm like, probably why, right? If they're cycling that much for compressor fill.
It's not even just that. The relays, if they have straight DC power on them, they're not rated. This cycle count's almost half.
Yeah.
So that's why you need that pilot relay. Now, we have a rack and it's still running like this. I fixed it at 2:00 in the morning.
Mm-hmm.
It was an Aldi and solid state relay burned out. I used the the digital output side of the CPC board. So like the anti-sweat controller.
Yeah.
One of those on a solid state relay from a normal relay from a DC.
Today's episode is sponsored by the Refr Shield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales at westermeyerin.com. That's WESTERMEYERIN.com.
From it just being on a relay,
mm-hmm.
It has not failed yet. I like using the anti-sweat controller for that.
You're talking about the relays that they use in the Target, like the anti-sweat panels, where they're actually just giving it a DC pulse voltage with one of those something like that.
Mac. Yeah, I use one of those because they had a board in there. It's not the 4AO, it's the 4DO. Yeah. I ended up using one of the 4DO boards, and it worked flawlessly.
That's what they're made for. They're made for a lot of cycles. You know what I mean?
I think that's a better option for those relays than using an actual RO board.
No, I agree because like I said, once again, you have mechanical, and it's funny. So when I teach class, like I'll open up an S3C, right? Because I'll show them the 4 relays that's on there, right? Because you have the relay for the fan, you have the relay for the light, you have the relay for the defrost, and then you have the relay for the solenoid, and then it says /pulse. And I was like, we got 4 relays here. How many relays are you going to expect to see? So we break it open, and then there's only 3 physical relays, and there's just a big black transistor like sitting in there. I was like, that's why. It's like the pulse valve, if you would put that on a regular output, it would end up burning it out.
Yeah, no, that's why they do it. Other thing I wanted to bring up, because this last 2 startups I did, they haven't been pulsing the oil drain solenoids off of level. They have a level sensor. They're doing it off of time.
How many minutes?
So it's in 2-minute intervals for 30 seconds.
2 minutes.
So every 2 minutes, it turns on for 30 seconds, and then it's off for 2 minutes, then 30 seconds, then 2 minutes, then 30 seconds. Interesting.
Yeah, but wouldn't that be more than what potentially?
Oh, it's cycling way more.
That's what I mean. Like, why the hell would you do that?
Because you're trying to get every ounce of oil out of the damn thing. So that's how older microthermal would do it. It would pulse more when it was transcritical to try to drain all that oil out before it gets carried out, because the carryover rate's so much higher. And it was doing that, but that's how the last 2 different OEMs are cycling off of time.
Yeah, but that's going to burn. They're still using the solid state relays, or no?
Yeah, they still have 2 solid state relays in there. Yeah, I don't think it's going to really derate it. Is it working? Yes. Is it simple? Yes.
It makes more sense that you would, because I don't know. I think that having it set up the way it was with the actual level, I guess you can still see when it fills up. But my point is that you can see how fast, like upon startup, you can see, okay, it took X amount of seconds at this pressure for it to blow out into the separator. And you can use that as a diagnostic tool, just like you can see typically when rack runs transcritical. I know we fucking said it was going to be basic, but whatever.
Down the rabbit hole we go.
Oh my God, always. So if you're going to see it in transcritical mode, like pulse a hell of a lot more, right? Because you're using so much more oil. And so I don't know. I just think that's a good diagnostic tool, because if you see what it is doing during subcritical operation, then all of a sudden it's just pulsing a bunch, then you're like, oh, that's a good indication that maybe I have a compressor that's bad. Maybe I have some flood back. You know what I mean?
No, I agree. I think the level sensor is still there and it's logging. I think it should be both. I think it should be, me personally, I think it should be on demand of a level sensor, and if it hasn't cycled in 5 minutes, maybe do a drain. Okay, so I had a good one. This got brought up.
Okay.
So it's midnight, brand new CO2 racks down. It's got no load on it. It blew most of the gas off, and none of the compressors have oil. The oil separator's full oil. The pressure's all equalized. How do you get the oil out?
Say that one more time.
Most of the gas is gone. Racks down. All the compressors are out of oil pretty much. One maybe has a tiny bit in it. And all the pressure's equalized. How do you get the oil to feed to the compressors?
How much pressure is in the system?
500 pounds, 600 pounds.
Isolate the compressors and bleed down the pressure, and then leave the pressure in the reservoir and use that on its own power.
So this is how I've been doing it.
Okay.
It's maybe another one of those.
I feel now there's going to be a lot of those. You know what I need to do? I need to make a button. I'm going to make a button now. I'm going to make a button. So I used to have a button that whenever Kevin would say something stupid before, like I knew about editing real bad, like I would push the button, but it would always be too late. Like he'd always start saying something horrible. And then I go to push the button and it was in the middle of it. Didn't make any sense. But I think I'm going to before you start one of these stories from here on out, this is done by professionals. Please don't try this at home.
Warning. The following stunts were performed by professionals. Do not try this at home.
So oil separator's chock full of liquid.
Mm-hmm.
Or not liquid, it's oil. It's like chock full of oil. It won't drain to the reservoir because it's all the same pressure. It won't go to the compressors. So I closed the vent line like 3/4 the way. Mm-hmm. And then I took the discharge line ball valve, closed that like half to 3/4 away. And I started the one compressor with a little bit of oil in there. And let me tell you, if that oil didn't come flying out of that oil separator like instantly.
You just bumped it?
I flipped the switch. After I reset it, it popped on for 30 seconds, and it was enough to build a pressure difference because the discharge line slightly closed. You still got the discharge, like all the safeties are there, so you're still safe on that. But it was enough to create a pressure differential to get that oil separator up to 600, 700, 800 pounds, and then feed that reservoir, and then feed all those compressors. Enough to get the rack to start back up. That is the best way I've been able to find to get these things stalled when they're stalled like that, besides putting oil in them. I don't want to put oil in them because then you end up with a ton more oil just to start the rack back up.
Someone was complaining about that today. They're like, yeah, this guy told me to just fill it up with oil. It cost me a bunch of money because then I ended up having to take it all out.
Expensive.
Dude, was it $400 a gallon?
Something like that. It's expensive.
I'm gonna start selling on the black market.
Yeah, it's expensive, so you don't want to be wasting it. And usually it doesn't blow off. Nobody's putting reliefs on an oil reservoir unless they're real dicks. It'd be a real dick to do that. Some engineer would have to hate some service guys for that. Can you imagine that going off?
What, the oil reservoir relief?
Yeah.
Someone wants to get punched in the face for that.
Yeah, that would be terrible. But So that's what I've found in order to like keep these things from starting back up, in order to get them to start back up. And then the other thing I had was that CCM 40 that walked the stem off.
Yeah, how does that happen? I'm still like confused on that. Was it programming or?
It was, I don't know if it was a combination of misprogramming and wiring when we went to go test the valves, but I've seen this twice now on 2 different racks. I've seen the CCM 40s walk off the motor housing, walk off of the piston. And it sucks because in order to take this apart, so when you take this valve apart, you unscrew it, and the piston is stuck inside the cage. You have to have a special tool to get it out. It's not really, you can make it out of a flat bar and a grinder, but the piston is stuck in the cage. So what you have to do is take the valve head and screw it on 3 turns, and then try not to turn it, like the piston to turn, try to get it to turn with you as you're screwing the valve back together.
I think that would be like leak locked or something in place. So
there's nothing on the end. There's
no clip, no nothing. Just nothing. On a certain amount of threads, and they're like, "Oh, just send it."
Yeah, and I think it just rides the face of it. Like from everything I can see, it literally looks like it just rides the face of it, and it just doesn't strip out that way somehow.
I think someone's sending me a broken CCM because they had problems with the HPV. We had talked about this, I think, last week, but they had problems with the HPV. And the 326, I don't think they really had any problems with the HPV, but they had problems with the 326 that was driving the BGV. And yeah, so the BGV went bad and then ended up shorting out the output for the BGV. So it basically valve killed the controller, right? And dudes, it was apparently the last one in the country.
So if I have a shorted 326,
yeah,
I instantly replace the BGV. I've been burned on this 3 times now.
Yeah.
Go ahead. Sorry.
No, I was going to ask. Like it was like it took out you didn't know what happened, so you checked because a lot of times once it shorts, it basically then just juices that controller once it shorts.
Correct.
I wonder if they sell a bipolar. I guess if you have a filter, right? Like Danfoss used to have before they stopped making them. I wonder if it would take out the filter rather than the actual control. No, actually, you know what? Never mind. No, it didn't, because this guy had a filter in place and it didn't
Still took it out.
Yeah.
Damn. So I've been burned by this, and I had one at a store, and it got my ass. So guy came and got a 326. I'm like, God, I've never had one fail. So I'm like, okay, to check it out real good. Burns it up instantly. I'm like, what the hell? Gets another one from me. I'm like,
oh yeah, you told me about this one.
Puts it in. It runs for 4 days. Burns out again. I go down there. I'm looking at it, and then I take the valve apart randomly. If it would open more than 80%, if it would get to 80%, it would short out.
Oh, so it wouldn't do it until like later.
It wouldn't do it till it was hot. It wouldn't do it till the flash gas got to 80%. And then in there was a bad spot, and it would hit the side of the motor housing. I still had it in my truck before I switched vans. Like you could literally take the thing and just, it would be fine. It was tight. And then it like 80, 90%, you could just shake the stator all over inside of it. I've never lost a CCMT valve though.
Except for the other week.
No, that was the CCM. The CCMT is the high pressure tap ones.
Okay.
So I've yet to lose one of those. It's always been CCM valves.
So you know what? I got something to talk about. This is actually going to be good since we're incapable of doing a basic. Next time you got to tell me that we're doing a basic episode, because then no, that's all right. It's fine. I'll prep something next time, because
every time we talk about it, it ends up being a good.
I know, but I was just like, it's not advanced CO2 refrigeration. You don't. It's whatever. It's fine. But it seems like that's what a lot of people are having problems with.
There's a lot of it going on.
Yeah, dude. We actually, now thinking about it, we have to have another Q&A. It's always good. We just got to plan it out better.
Some mentoring.
He's such an asshole. Oh my God. Oh, dude. Sorry. It's my son's fault. He keeps singing that song. Never gonna give you up. No, here, hold on. Yeah, so now I got some pictures downloaded. So let me just go through what this guy was sending me. Blah, 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 blah.
Sure, you want to see that?
Stop it. Stop it. All right, so no, I'm not going to invite anybody. That's dumb. All right, present. Share screen. Naughty pictures. All right, share. All right. So that's the little itty bitty tiny filter that I've never seen one this teeny tiny. And this was for the hot gas injection. So he was having a problem where the rack at a certain point of time, around 6 o'clock, the thing would fail. It rhymes with Raldies, and basically it would run fine, and then it would just not run fine after a little bit. And so what we found out is the hot gas solenoid, even though it was feeding. So here you can see the suction pressure, and then you can see the superheat. And then once it started delving down below the no point, like below 18, I think actually, yeah, it was set for 18, which I don't understand why it's set for 18. That doesn't make any sense, because if they're minimum of 20 degrees of superheat, like on the transcritical side and the medium temp side, I don't understand why you get it clear the no zone. Yeah, you can keep laughing at me. It's fine. So you can see, like, around that same time it failed, right? So I hear him beating on the valve. I hear tink, tink. I'm like, what are you doing? He's like, nothing. I'm like, you're beating on that valve to try to get it to feed. It's, no. I was like, you need to take it apart. But apparently on this rack, there was no shut off of where it connects for the BGV. There's no isolation. No, there was no little itty bitty valve. So yeah. So anyway, so you could see suction pressure, superheat, suction pressure, superheat. And then I had him send me what the hot gas dump looked like. And then it was working for a little bit. And then you can see it just grenaded and then just went down. The other theory that I had was, like, why it ends up failing at 6 o'clock. Because then I had the liquid injection valve that hadn't been feeding at all. That wasn't feeding. And then the next thing I had him basically measure, put on the graph here on MT, was the discharge temperature of the low temp compressors. So my theory was it was trying to feed, and the only reason why it didn't fail and the superheat didn't go into the no zone is because your low temp compressors were still feeding, because you didn't have anything in defrost. As soon as one of the low temp circuits would stop feeding, the discharge temperature went down in the toilet, and then basically didn't allow it to warm up the suction line as much as it was. Because you can see, like, it was feeding here, but it wasn't doing really jack shit. Like, it just kept wanting to feed. And this is when he started beating it. Right around this zone. So then it started feeding fine. And then once again, it stopped feeding. And then this is the night that it failed again, because he couldn't get it. It was, I think, Saturday when he found out that it was bad. And like I said, there was no shutoff for this hot gas dump line. So unfortunately, it just would have made it difficult. Look at that job too. Isn't that cool?
Why is the suction pressure like 500 pounds?
Suction pressure. I think that was suction pressure. Oh, it's because rack failed. Where do you see 500? Or that's flash tank. That's the other thing I still haven't figured out.
That says suction pressure.
Where?
At the top of the graph, it says suction pressure.
Oh, it's still. I don't know why it's stuck there. That's weird. I don't know. Hold on. For some odd reason, it was doing something stupid. I was showing more pictures, and it was just.
I was so confused. I'm like,
no.
Talking. I'm like,
yeah, because I was going through all these pictures. Anyway, all right, filter. And you can see the suction pressure basically fail, and it failed right around this 6 o'clock mark. So we were trying to figure out why it failed. Fine, turns it back on, and then right around 6 o'clock fails again. So that's when we started looking at, okay, suction pressure, superheat, fine, then drops. And so, okay, good, it's still switching. Okay, so then we started graphing the hot gas dump. Seems like it's doing something. I know it wasn't feeding as much as what it should have been. But this is where I was saying, where basically he has the, let's see, hold on. Suction pressure and then superheat. All right, suction pressure, superheat, and then when the hot gas is in feeding. So you can see on, off, on, off, on, off. And then once he did that, he also put the liquid injection valve, because I wanted to make sure it wasn't going off on, because I know these racks, they'll inject hot gas and liquid at the same time to keep the suction pressure up in the program. And then this is when I had the epiphany. I was like, something has to be shutting off, because it kept failing around 6 o'clock or so, somewhere in that range. And you can see that right here, the discharge temperature basically dropped all the way down because the system went in defrost. When that happened, this is what I was talking, the no-no zone. Basically went below the 18 degrees that it was set for, dropped it down to about 15. That's when I think it started oil filling. But I think mainly because his hot gas it wasn't barely feeding.
See, I don't really think those hot gas solenoids even do much in those racks, but when you lose that freezer load, done. Like, especially if you have any, I
that makes sense though, because you're getting that additional superheat from that compressor.
Oh yeah,
yeah.
When it shuts off, those racks like struggle big time. Most of the time, what I've been finding, especially in an Aldi, is if I'm having like superheat issues, I just scroll through the XMs, look through for P6s, because certain manufacturer had the run of bad sensors, and like every store you'll find one or two suction temp sensors reading like 100 degrees.
The other thing I told him to do, I was like, if you know how, because there's not that many cases at a Schmaltzy's, right? So if you basically know that, okay, this case at 30% is able to achieve the superheat that it's supposed to, but you see another one that has a higher superheat and basically it's open to 60%, that's an indication that it might be giving false readings, and they should probably go downstairs and see what the hell's up going on. You know what I mean?
That's why I like with Microthermal building out a page with all the coils on it and with all the case controller information. And you could literally take like discharge air, EEV percentage, superheat, coil outlet temp, and like suction pressure and lay it all out. And then you could look at like a lineup of cases and be like, oh shit, case A, it's at 400 pounds. Case B, it's at 575. Something's not adding up. Where the other 175 pounds come from? Or like, hey, case A's EEV's at 100%, case B EEV's at 0%, and it's flooding out still.
Then we have this beautiful thing. He said the sensor was barely shoved in there. And then, yeah.
Is it for the drop leg?
Yes, it is. And it's not even wrapped. So that's awesome too. But this was the solenoid. So there's the shutoff valve there. And so even when he shut it down, it just where it ends up going in there, there's no shutoff valve there.
That sucks.
Yes.
A birdie told me that if you take those orifices in those solenoids and drill them out to a DN6, they work much better.
I think I knew what the birdie's name was.
Zero Zone uses a DN6.
Yeah.
You could cook a hot dog on that thing.
So the other thing that I still haven't figured this out because the cat hasn't went back and he was there all night and he was getting frustrated. But so the flash tank would not register, like wouldn't stay between what the settings were of what he was supposed to be getting. Like we went through the 326 and it was set for a reference of I think 530.
530?
530 or 520, 530 PSI, I think.
It's pretty high.
520. I don't know. I don't remember. I think it was 38 bar. But anyway, it just wouldn't go like higher than what it was.
So I bet you I know what it is. There's a max pressure and then there's your reference pressure. And if they're not a bar apart.
It was though.
It was a full bar apart.
Yes, because that was the thing. I was like, just for shits and giggles, because I think it was 550 something is what it was set for like the max where it would actually close down the HPV. I was like, just raise it just like one more bar. You know what I mean? Like just raise it a little bit. Not that it would got that close and then like basically interfered with it. You know what I mean?
That's weird.
Yes.
That one looks beautiful right now.
The what? The what looks
beautiful? It looks beautiful right now. Like at 508?
Yeah. And actually, I think this pressure, I think it was actually maintaining right at 520, but he had it set in the controller for 530. But like I said, I know this is off because we verified the 326 and he verified it when he replaced it just to make sure it was reading right. And this is reading like 10 pounds off. So, hey, this is an older rack. Could be reading a little bit farther off. But yeah, everything else looked freaking great. The only thing that was hokey was the oil pull. That was fine. Yeah, just the temperature right then was fine. But like at one point, like as soon as you lost that one low temp compressor, it just forget it. It didn't like it at all.
Yeah, that is a huge problem with them. Like, I mean, once it loses that low temp compressor, it's done. And if you have pieces of rubber in your rack, you're pretty much done too.
Pay no attention to my desktop.
It's like a beautiful mind.
Oh my God. The other one, the other one's even worse. I have two monitors full of shit because I'm like, oh, I'm working on that. Oh, I'm working on that. Oh, I'm working on that too.
Mine's starting to build up.
Yeah.
My laptop's bad.
I want to get the carrier people on. They're always impossible. Hey, Steve Moss, if you're listening, you need to call me and you need to get your ass on here because I want to talk about your carrier thing before I just start talking about it randomly. Did you see anything about that yet?
No.
You didn't?
No, I live in zero zone world right now.
Oh, yeah?
So
how's that going?
Good and bad.
There's always
they build a nice rack.
Oh, they do.
They build a nice rack, and it's 100% engineered here.
Oh yeah.
Yeah, they don't outsource any of their engineering. So,
you sure about that?
I'm pretty sure.
Okay,
guys, we'll wrap it up.
You're gonna call it?
Yep.
All right, maybe next time we can actually keep with basic. Horrible. Why did the rabbit hole just goes deep?
It just starts and goes deep.
That's what she said. All right, guys, have a good night.